Yeah, so the way the recording works, guys, is you see the little red dotted line that goes around that thing, right? Whatever's inside that window is what's going to appear on your YouTube video. If you go and click on it, you'll hear my voice in the background. Okay, you'll hear your voice in the background. If you want to participate in any of today's activities, you'll hear yourself, which is kind of neat. I can pause it. I can go back, whatever. So it's kind of nice. But anyway, so you want to buy these hot fries? They're $1.25. So you put $2 in the vending machine, you better get 75 cents back, right? Okay. Now, if you get 75 cents back and the next person goes over and puts $2 in the machine, they're expecting to get 75 cents back, right? They're not expecting to get 50 cents back or $1 back, right? I mean, they'd be happy if they got $1 back, but nonetheless, right? They would expect to get the same amount of change back, okay? That's going to bring us right into what we're going to talk about today, okay? So here's what we got. We have what's called an independent variable and a dependent variable. Independent variable is going to be the amount of money that I put into that machine. Okay? So I put $2 into the machine. That's going to be called my independent variable. Check it out, guys. What's another word that I called it? The input variable. Oh, yeah. I take those $2 and I input them into the vending machine, don't I? And I expect two things as output. One of those things are my hot fries, right? Those better come out, all right? Otherwise, I got to shake the machine a little bit. And I better expect to get what? My change, right? So right now I have my input, and then I have my output, right? I have my input, I have my output. I want you guys to write the following next to these things. When I talk about inputs, I'm talking about X values. And when I'm talking about outputs, I'm talking about Y values. So far makes sense, right? Okay, so I take my money, I put it in the machine, I get some change back. I expect to get the same amount as everybody else. Everybody agree with that? Cool. Okay, ready? Watch. Now I'm going to show you how that's going to relate to what I'm going to do right now. Here I have two relationships. They're both graphs. One's like an oval or an ellipse. The other is a what? Parabola, right? It's a quadratic function, no doubt, right? So this says draw the line whose equation is x equals 3 on both graphs. Draw the line that is x equals 3 on both graphs. Well, x equals 3 is right here. And x equals 3 is right here. What's another line? What's a phrase I can use to describe that line? Give me a phrase I can use to describe that line. Real simple phrase. That line is? Okay, I agree. It's straight. Give me something else. Vertical line. Yeah, it's a vertical line, right? This is a vertical line. So x equals 3 is a vertical line. Now, right now, your question that you should be asking yourself is, why am I putting a line on x equals 3? Right? I would have some issue with that. I'd be like, what is he doing? Why are we doing that? Okay. If you look at this first relationship, do you agree that this first relationship has some points of intersection between that line that I just drew and the function that was there to begin with? How many points of intersection? There are two of them, right? Let's identify them. Got one here, got one here. This is at the value 3, 4. This is at the value 3, -4. Yes? Okay, good. Let's write those down. Relationship A has 3, 4 and has 3, -4, right? Relationship B gave me how many outputs? Only one. And what is that particular point? 3, -2. All right. So right now you're thinking to yourself, what is this guy talking about hot fries for? Where'd that come from? How's that relating to anything that I got with these two pictures and nothing going on in terms of descriptions, right? Well, let me give you this example that correlates to what I just said. let's pretend that the 3 is the input. Why is the 3 the input? What kind of a value is it? An x value. And I said at the beginning that input values were x values, right? So if I put the same amount of money into the vending machine as somebody else, we would both expect to get what? The same amount back for the same item, wouldn't we? But here's the problem. Look at example A, or relationship A. Somebody puts $3 in the vending machine and they get a result or an output of what? 4. But then somebody else comes along and they put $3 in the vending machine and they get an output of what? -4. That's a problem, isn't it? Okay? What happened is we no longer have a function. What that means is the following, guys. A function is something that is predictable. In other words, if I put in something, I know what should come out of it. It shouldn't be ambiguous. It shouldn't be, well, you could get 4 or -4. You either get one number or you get no numbers, but you certainly don't get 2 numbers. Because do you guys agree that in relationship A, I could have actually taken that line and I could have actually put it over here, right? How many times does it cross that particular graph? Right now it's none, right? But if I can move this line anywhere where it touches this graph in more than one spot, I have an issue. Now somebody might say, well, hang on, Picardo. What if I put my line right here? Now it only touches in one spot. It only touches right here. But here's the problem. If there is any scenario where it touches it more than once, I got a problem, don't I? I got a problem, okay? Do I have a problem with relationship B? I put in $3 and I get -$2 back, or however you want to think. I mean, that's just the analogy that I'm using, right? If I input one thing in relationship B, I get how many outputs? I get one output, okay? So if you input something and you can determine precisely what the output is, it is a function. Because in that first example, I couldn't do that, could I? Okay? So which of these is a function and why? Relationship B is a function. Because each input has only one, bless you, has only one output. Each input has only one output. Doesn't have 2 different ones, it has one. Making sense so far? Now, happens to be that we have this test. It's called the vertical line test. And the vertical line test is super easy to do, isn't it? Because what do? I draw vertical lines anywhere on my picture. And if I can cross my graph more than once, it is not a function. It is no longer a function. But if I can only do it once, it is a function. Cool? All right. Now, guys, what we're going to notice is that this course is extremely diverse. In other words, I use the word function, and I gave you guys a picture, right? I gave you a picture of 2 different things that we were going to compare and contrast. Okay? Here, what do I give you? I give you a picture, but then I give you 2 tables, and then I give you circles with arrows. What is all that about? Okay, well, let's see. It says, which of the following is not a function? Okay, so we have somebody who suggests that they think it is D. We'll see. Is A a function? Why is it a function? Give me one really simple, straightforward answer. It passes the vertical line test, right? And those of you that took algebra last year probably learned that, didn't you? Okay, so this passes the VLT. So we're happy about that, right? Passes is a function, right? Relationship B. Yeah, oh yes. You were going to explain relationship B. Very good. Let's hear it.
None of the x values share the same y.
Yeah, none of the x values share the same y value. Now, I'm even going to go a little bit further. None of the x values repeat. If none of the x values repeat, then there's no way that one x value can go to two different y values because there's only one instance of each of the x's, right? Make sense? Okay. So this is a function. Now, the one thing that people don't like is they don't like this, right? Like, hang on a minute, those repeated. Arnold, they repeated. You just said a minute ago that they can't repeat. Hang on a minute. Here's somebody who comes in and puts this in the vending machine. And you could. Did you guys hear that? I pushed it and it said hit that button again. Didn't you hear that? It was insane. That was the most ridiculous thing ever. It really happened. You put this in, you get a buck. You put -1, you get 0. You put 0, you get 1. You put 1, and you get 2. Here's the thing. None of you guys put in the same amount of money, so I don't know if you guys got different things or not. Everybody was unique. Make sense? All unique inputs, right? I can have duplicate outputs. That's okay. That's okay. Relationship C, what do I have? I have x values of 1, 2, 3, and 4. They are all unique. They're all different, so I can't determine anything. So we got to be good, right? And relationship D. Here's the problem. This person right here did what? They put $2 in, and one person got 7 in return, and the other person got 9 in return. And so this is not a function. If they got 2, 7 twice. Yes. Yes. I get what you're saying. Yes. Okay. Guys, I'm going to show you another way to think about that, because everybody always says, they're like, Picardo, I really like the vertical line test. Like, why can't everything just be that? And what am I going to say? Well, not everything's representative of a graph, right? You don't always have a graph in front of you. But if you have what? If you have x's and y's, can't you plot those points, right? So if I called these x's and I called these y's, couldn't I plot these points like really like quickly? Like this? Here's a 7, here's an 8, here's a 9, here's a 1, a 2, and a 3. And so can I quickly plot these points? So I have the point 1, 8. I have the point 2, 7, and 2, 9. And I have the point 3, 9. So do these points pass the vertical line test? Well, there's the vertical line. Does that particular line pass? But does this one right here? No. And that's a way that you could take something and actually create a graph and do a vertical line test. Happy? Albert says that this relation is a function. Is he correct? Well, 0 goes to 2, 3 goes to 9, 2 goes to -1, and 4 goes to 2. What do you notice about all the x values? They're all different, so is it a function? Yes, it is. This is a function because all of the x values are unique. That's a way of thinking about it, isn't it? If all the x values are unique, we're in good shape. Really quickly, I'm just going to slide back here for a minute. What word did you see at the beginning of example C? Explain. Guys, I want you to do me a favor, and I want you to star that word. When you see the word explain, you need to write words. When you see the word explain, you need to write words. Okay, it means that you have to use vocabulary and sentences in order to give me an explanation, right, of what's being asked. Now that word explain is very different
than the word justify. The word justify means you can use any technique you want. So you might do some math. You might write some words. So this could be math. This could be words. This could be a chart. This could be a graph, right? It could be any number of things, right? You can do anything in your repertoire in order to get the point across when you see the word justify. But when you see the word explain, if I don't see words, it's automatically 100% wrong. Can't explain if you don't write words. Agreed? All right. Function notation. You guys are very familiar with functions. That's our entire unit here. And what we have, guys, is we have a notation that you should have been familiar with in algebra class. And what we said was that y is equal to f of x. This is another way to write any function that we want. This is called an input value. And what value represents input? X values. We said that right at the beginning, right? So when we put this value into a function, we get something as a result, and we call that a output, which is represented by what letter? Okay, so that's right back to the very first thing we said at the beginning of the class, right? X's are inputs, Y's are outputs. And so this notation should make some sense now, right? Where this came from. So whatever is inside of here is what we input into the function. So if I give you this example, here is a function f of x. And f of x is represented by 5x minus 2. What do I want to do? I want to find f of 3. Who can give me a good mathematical sentence that describes what I'm asked to do? Yes. I don't know your name. Yeah, I do. Jameson.
What I did was I put 5x. So 5 times 3.
5 times 3.
X is 3.
X is 3.
Minus 2.
Minus 2.
We divided 3.
You divided 3? Okay, hang on. Stop. Time out. There's no equation here. I like what you're thinking, but you agree that this 3 is going to take the place of this x. That's what you told me to do, right? So what's 5 times 3? Minus 2? Minus 2? That's my answer. That's all I need to do. Okay? In the next example, what am I going to do? I'm going to take negative 2 and have it replace the x value, right? So this is going to be 5 times negative 2 minus 2. What's 5 times negative 2? Minus 2? Okay, very good. So functions, in terms of what? In terms of evaluating them, is nothing more than plugging in and simplifying. What am I doing here? Plugging in negative 3. Where am I plugging it in? In for this 1x, right? So what is this going to look like? It's going to look like negative 3 squared. 9 plus 3 is 12. And we'll plug in 0. Just 3. What am I going to do here? We're going to take the 3 and plug it in for the x. So what's it going to be? 2 cubed. What's 2 cubed mean? 2 times 2 times 2, which is what? Don't say 6. 8. And here I want to evaluate 2 to the negative 2. Well, if you typed it in your calculator, guys, you're going to get 1/4. Just trust me. We'll talk about why at a later date. Hey, guys, there's a way better way to do all these problems. Way better way. And I'm going to expect that you can do this. Okay, here's one of them. All right, I'm going to go all the way back to this first example. what did I want to use for my x value in the first example here in A? 3. So one way, guys, that I can do this is by saying, okay, let's take 3 and let's store it. To store a variable, we hit the yellow button and then this button here, which is var, and we get the little arrow. So I want 3 to represent x, and now I want to evaluate what? 5x minus 2. So now if I just do 5x minus 2, what do you notice about the x value? It's bold. Bold means that it has something that it represents, right? So what does it represent? Well, 5x minus 2 represents 13, right? So that's one way that you can do it. But guys, what if I gave you like, I don't know, what if I gave you like 10 of these that you had to evaluate, right? You really want to sit here and go, okay, well, the next one I have to do is -2. So I'm going to store that in. And now I got to go up here and I got to copy this. And there's my -12, right? Didn't seem like it took that long, but if I had like 10 of them to do, it might seem rather tedious, right? So there's another way that you can do it. And in fact, this way is going to be really nice for what we're going to do tomorrow, well, Monday, okay? It's by using something called, and I want you to write this down, I want you to circle it, and I want you to star it. So we have the store function. Right, the store function's nice, but now we're going to have another one. We're going to have a function called define. So we're going to define the function. And how are we going to get to define? Well, the easiest way to do it is literally to just type in the word define. So let's go back to our calculator. We want to define f of x as 5x minus 2. So what I can actually do here is I can type in the word define, define. And I'm going to define f of x as 5x minus 2. And what the 5 of x equals 5x minus 2. F of x equals 5x minus 2. And when I hit enter, nothing happens. It just says, okay, you're done. You did it, right? What does done mean? It means the calculator's now stored this into its memory, right? So now here's what I want to do. I want to know what is the value of f of 3 and f of -2. Watch. What is f of 3? What's bold now? The f. Why is f bold? Because we stored something into it. There's your 13. There's your -12. So if I had you guys do like 10 of them, this is a quick and easy way you can do it, right? Okay. Define. Pretty simple, right? Pretty easy way to do it? Yes. Yes. So absolutely. And I was going to share that with you in a minute, but I'll do it now since you preemptively struck. Here's what you're going to do. This is another way to do it, guys. If you go to your calculator and you type it in, 5x minus 2, what are you going to get? You're going to get some kind of graph, right? Well, if I want to know particular points on this graph, specifically what happens at 3 and -2, there's a couple ways I can do it. One of which is to hit Control-T, and what does that do? It gives me a table of values. And so if I go to the values that I was interested in, which were 3 and -2, I get my solutions, right? So yeah, guys, one of the themes of this year is I'm going to give you lots of ways to do different things, okay? So here we have a bunch of ways to determine if something's a function. We have a bunch of ways to determine how to evaluate a function while we plug things in. All right, cruising. Guys, here I give you a chart. So here's what happens. Mr. Picardo over the weekend, and this is a true story, Mr. Picardo canned tomatoes, right? My wife decided that we needed to be a part of a collective food share. Anybody know what a collective food share is? Raise your hand if you know what it is. Good, I'll explain to everybody else. So farmers, right, they make some money by selling directly to grocery stores, but grocery stores are then going to take the product and sell it to me. So what happens? Well, the grocery store buys it for a certain price, and then they mark it up so they make a profit when they sell it to me, right? Well, some farms, they want to sell directly to the customer because they can sell it to me a little bit more than they can sell it to Wegmans because they know that they just cut out the middleman, right? So what they do is they'll say, okay, Mr. Ricardo, we will have you sign up for our service, and for $400 a year, you can come in twice a week, and we're going to give you a bunch of fresh produce, whole bunch of fresh produce, right? And so we got 50 pounds of tomatoes this weekend. 50 pounds, right? Beautiful, ripe tomatoes. So what are you going to do with 50 pounds of tomatoes? So I canned them, right? I canned them, so kind of cool. Anyways, so what I had to do is you have to boil the tomatoes, and then you put them in the cans, and then you put the cans into water, and then you boil the water, and it seals, right? Well, after it's done boiling, you boil it for about 45 minutes, you put it on the counter, and you wait for it to cool. Okay, so I did that this weekend. So I boiled water at 212 degrees, and I took it off of the stove, and I put it on the counter in a 65-degree room, and what's going to happen to the water? It's going to cool because of what guy? Isaac Newton. Isaac Newton has the law of cooling. And his law of cooling says that an object will cool predictably in a room over time until it eventually reaches the temperature of what? The room, right? It's not going to go higher than the room or lower than the room. It's going to hit the room, right? So we take it out. And after 1 hour, the temperature of the water has cooled to what? 141. And after 2 hours, the temperature of the water is cooled to what? 104. We just answered one of our questions. After 2 hours, we've reached 104 degrees. How about 6 hours? 68 degrees. Really difficult question to answer, huh? All right, and then for what value will I reach a temperature of 76 degrees? How long is that going to take? It's going to take 4 hours. So I can ask you questions flip-flopped, right? And then the last question of this particular exercise asks what? Between what times will the water reach 100 degrees? Because my chart doesn't have 100 degrees on it, does it? But it's got 104 and it's got 85, which means between the second and third hour. Between the second and third hour, I'm going to reach that 100 degrees, right? Any issues? Happy? Cool. What do I do here, guys? I didn't give you a chart, did I? No, did I give you a function like this? Did I give you any of these? No, what do I give you here? A graph, right? Same concepts are going to apply. What is f of -1? So in order to figure out f of -1, what is -1? An x value. So what do I need to do? I need to go to my graph, and I need to go to an x value of -1. Where am I? I'm right here, aren't I? What is that point? Ah! -1, 0. So f of -1 equals 0. Always left and right first, up and down second. Okay, now I want to go to 1. So I'm going to get on my function, and I'm going to go to 1, which is right here, isn't it? That's at 4. So f of 1 is equal to 4. And how about f of 5? Where's that going to bring me? It's going to bring me here to -4. Right? So same type of questions, right? Except now asked with a graph. Guys, these next two questions seem ambiguous, and they seem sort of like filler questions. These are two of the most important questions of the day. It says evaluate f of 0. All right, well, we just did that before, so go to 0, and where am I? I'm right here, I'm at 3. Hey guys, what's special about that? Oh man, you are on game. On a game. Hey, that's the y-intercept, isn't it? Isn't this black point right here where this function crosses the y-axis? So that has a special name. This is called the y-intercept. So f of 0 is always the y-intercept. Guys, I can promise you, guarantee you, 100%, no doubt about it, that is one of the questions on your exam. Star this. F of 0 is always the y-intercept. And what is the definition of a y-intercept? It's the point in which a function crosses the y-axis, right? You guys know that. You've done it a lot with lines. You did it with some quadratics. All right. What values has this function equal 0? Guys, this is what this question is saying. It's saying what x values give me a y value that is equal to 0. Isn't that what that's really asking when I write it that way? What x values give me a y value of 0? So let's go to our graph. Y values equaling 0 are along what? The x-axis. Can we all agree that this is the point 7, 0? So that has a y value equal to 0, right? And can we all agree that this has a y value equal to 0? And what's that point? 1, 2, 3, 0? And didn't we already write one down right here? So can we all agree that f of x equals 0 at -1, 3, and 7? Okay. So f of x equals 0 when x equals -1, 3, and 7. What special features or what specific thing can I say about those points? Give me a word. They are? What kind of intersects? Okay, so f of x equals 0 at a function's x-intercept. Hey guys, you didn't really use the word x-intercept last year or 2 years ago in algebra. What word did you use? You didn't really use x-intercept. Trees have them. Roots. Sometimes you hear this word used. Zeros. What are the zeros of a function? Guys, if I say what are the zeros of the function, I'm asking you for the roots or the x-intercepts. Those are all synonyms. Synonyms mean words that are the same, right? Yeah. Guys, star this. This is another one of those things that I know for a fact is extraordinarily important this year. How do I find the roots? How do I find the y-intercept? I either do that or I do that. I either plug in 0 or I set equal to 0, right? Okay. Between what two integers does the largest solution of f of x equals 3? This is where if you listen in class, guys, and you pick up on the little hints and tricks that I do, things become so much easier. Because if the last question made sense, this question will make sense as well. What do I want to do here? I want to know what x values give me a y value of 3. What x give me a y value of 3? Okay, so I'm seeing hands up. Awesome. There's 2 of them, right? So let's go up here. Where do I, oh, there's actually more than 2 of them. Where do I have a y value of 3? Well, isn't that y equals 3? Does this graph cross that? How many times? once here, and once there, right? Now, if we read the question carefully, what did the question specify? What is the largest solution? Well, what's this solution? 0. What's this solution? 2. And this solution is something between 7 and 8. Awesome. All right, last little bit of the day. This one right here, guys, again, when you first read it, you're going to be like, what? Huh? What's it? For the function y equals g of x, it is known that g of -2 equals 7. Which of the following points must be on this graph? Well, what is that? What is that? Is there a point that has an x value of -2 and a y value of 7? There's your answer. Right? But it's amazing how oftentimes the question as silly as that can trip us up, right? Make us have a mistake or make us cause an issue. All right, last question of the day. Physics students drop a ball from a 50-foot building and model the height of the ball as a function of time with this equation. Use tables to figure out when the ball hits the ground. Again, guys, the devil's in the details here. It says that this function does what? It models the height as a function of time. So what does this represent? The function models height as a function of time. What that means when you hear that phrase, it means that time is used to determine the height. So the input value is time, the output value is the height. And this problem is so nice to even sort of use H&T, right? So what happens? Guy stands on top of the building, drops the ball, right? What happens? The stop clock starts. The ball's gonna what? Fall, and what's gonna happen to the height? It's gonna decrease, right? So I wanna know how long is it gonna take for the ball to hit the ground? So my question to you is this. I'm essentially trying to figure out when the height equals what? 0. Now, this says to go to a table. I already see a problem here. Do you? What is it? Okay, yes, I agree. You're right. You don't have a calculator. I'm going to show you what it looks like. And then you're going to see what the other problem is, I hope. So it's 50 minus 16. Am I going to use t? I'm going to use x. Calculator understands x's and y's, right? Doesn't really get t's. So I'm going to use x to represent that, okay? And I'm going to hit enter, and I'm going to see something. But this problem said specifically it wants me to go to the table. So I'm going to hit Control-T. So here's my problem, guys. My problem is at 0 seconds, the ball is where? 50 feet up. Why? Because the guy's standing there like this, saying, I'm going to drop it. We'll drop it. Then releases, right? So after 1 second, the ball is 34 feet in the air because what happened? The ball dropped. And after 2 seconds, the ball is -14 feet in the air. Well, unless that ball was super, super heavy and there was a hole in the ground, it probably didn't dig itself 14 feet in the ground, right? It probably what? Just hit the ground. And where did it happen? Somewhere between, 1 and 2. Because where am I at 0? In the air. Where am I at 2? Or I'm sorry, where am I at 1? In the air. Where am I at 2? Below the ground. So I must have what? I must have hit the ground somewhere between 1 and 2. I got a problem. Here's my problem. I didn't exactly hit 0, did I? So, I mean, I can certainly assume that I hit 0 between 1 and 2, but I don't actually know what that value is. Now, luckily, the question said between what two values, didn't it? Okay. What if I wanted more specificity? What if I wanted to know to the nearest tenth of a second? Because between, like, if it's only going to happen between 1 and 2 seconds, like, that's not really all that valuable. Yeah. That would be changing the function, though, right? I don't really want to change the function. Yeah, I don't want to change the function. I get what you're going with. I don't want to change the function, though. If I change the function, it's going to change the way the ball drops based on the equation they used, right? Don't I need to change the table? Like, I don't want this to go 0 to 1. I want this to go 0 to 0.1, right? So here's what you can do. You guys see how there's like a little black ring around this? And if I click on this, you see how the little black ring switches, right? So if my little black ring is around this, and I go to menu, it gives me an option to change the table, and I want to go into the table settings. Well, this table starts at -1, and it steps by 1 at a time. What that means is if you're starting at -1, jump by 1. So -1 jumping by 1 goes to 0, jumping by 1 goes to 1 and 2 and 3. So if I wanted to round to the nearest tenth, what might I change my step to be? 0.1. If I make it 0.1, I'm going to go from -1 to -0.9 and -0.8. So I'm going to get more accuracy now. You guys see how that did that? And so now, if I wanted a better answer, what would I do? Well, I would move my, I gotta go this way. So at 0, where am I? All right, and now what happens? I know what happens between 1 and 2. Still in the air, right? Still in the air, still in the air, and now I can be way more specific, right? What happens? It happens between 1.7 and 1.8 seconds. So I can get way more accurate if I wanted to, right? I can get way more accurate if I wanted to. How are we doing? Making sense? Beautiful. Guys, for your assignment, so the way that this packet is put together, what I have is I have all the notes in front in order for this unit. If you go like 2/3 of the way through this, on the bottom, see how the numbers increase as you go? Yeah, that's typically what happens in a book. Well, eventually they're going to restart, and they're going to restart at 1. And when they restart at 1, you've brought yourself to the beginning of the homework packet, all right, or classwork packet. Now, what you notice is that this lesson was titled what? Functions Introduction, right? Well, what is the first assignment in here listed as? Functions Introduction. Yeah, so that's your first assignment. Now, one thing that you're going to notice is that as you flip through that, there's 7 questions in all. Question number 7 specifically highlights something that you need to do. It says using tables. If you go to question number 5, it says using store. So there are some areas where I expect you to use a calculator. I understand that not everybody has a what? A calculator at home. So next class, I'm going to give you about 10 minutes at the beginning of the period to go through the questions that you need to use the calculator on. Okay? So everything else should be done. The questions where you need a calculator, you can come in the first 10 minutes on Monday and get that started. How are we doing? Pretty good? Awesome. All right, that's it for you. You got 4 minutes here. You can get started on that.